Welcome to all. I am Dr. M.R. Kadam, MSc in Analytical Chemistry and PhD in Material Science.
Synthetic polymers. Introduction. Polymer is a generic name given to a large variety and number of compounds having high molecular weight. Life is unthinkable without polymers because they form the fundamental structural and functional molecules of all living forms. The starch, cellulose, collagen, hemoglobin, DNA, RNA etc. all are polymeric molecules. Not only this, the polymeric materials have become part and parcel of our day-to-day life. The food we eat, the clothes we wear, the paper we write, the pen, the brush, the mat we use are all polymeric materials. There is hardly anything that cannot be made from polymers. Hence, it is rightly said that we are living in polymeric age. In this topic we will discuss some aspects of high polymers. Literally the word polymer means many parts. The low molecular weight repeating molecules or their residues from which the polymer is formed is called monomer, meaning single part. A large number of these monomeric units combine to form a giant polymer molecule. A polymer is a high molecular weight compound formed by the linking of large number of one or more types of monomers. They are complex and giant molecules. The polymer molecule contains a structural identity repeating itself several times. These repeating entities are called repeat units or the monomeric units of polymer molecule. The size of the polymer is decided by the number of repeat units present in it. The reaction by which monomers are converted into polymers is known as polymerization. The polymers synthesized from only one kind of monomers are called homopolymers as shown in above figure, A. While the polymers synthesized from more than one kind of monomer are called copolymers as shown in above figure, B. Chemists use a shorthand representation of structural formula of polymer molecule and the polymerization reaction. The monomer is shown on the left hand, reactant, side of the equation. On the right hand, products, side, the repeating polymer unit is enclosed in bracket. The lines passing through the bracket indicate that the chain continues on both directions. The subscript N shows how many times the repeating unit appears in a polymer molecule. Frequently the end groups of polymers are unknown. So, they are not included in the formula. Classification of polymers. Polymers can be classified on the basis of their origin, chemical structure, physical properties, mechanical behavior, thermal characters etc. Some of these are discussed here. 1. Classification based on the origin. They can be of two types. Natural polymers, obtained from natural sources, plants and animals, example cotton, silk, wool, rubber etc. Natural polymers usually have more complex structures than synthetic polymers. Synthetic polymers, obtained by the polymerization of low molecular weight monomers, e.g. polyethylene PVC, nylon, terylene etc. The chemically modified forms of natural polymers like cellophane, cellulose rayon, leather etc. are called derived polymers. 2. Classification based on composition. They can be organic polymers. Their backbone chain is essentially made of carbon atoms, for e.g. most synthetic and natural polymers belong to this class. Inorganic polymers generally do not contain carbon in their backbone, e.g. glass, silicon, rubber etc. Alternatively, they can be grouped into homopolymers containing only one type of monomeric units, example nylon 6, cellulose etc. and heteropolymers containing more than one type of monomeric units, example nylon 66, proteins, nucleic acids, etc. 3. Based on method of preparation. Depending on the type of polymerization reaction used for polymer synthesis, they can be grouped into two types. Addition polymers. They are the polymers formed by addition polymerization of olefinic, alkene, monomers. Here the monomers just add on to form polymer. The empirical formula of the polymer is same as that of monomer, and its molecular weight is equal to the sum of molecular weight of number of monomers in the polymer molecule. These reactions are catalyzed by peroxides or acids at 473 K and 5.01 x 107 nm2 pressure. By using Ziegler catalysts, lower temperature and pressure can be employed. Example: polyethylene, polypropylene, polyvinyl chloride, etc. Condensation polymers. They are the polymers formed by condensation polymerization. Here two reactive functional groups, example COOH, NH2O, etc., of monomers condense with the elimination of some small molecule like H2O, NH3, CH3O, etc. to form polymer. So, the molecular weight of a condensation polymer is less than the sum of molecular weight of monomeric units condensed to form the polymer. Example: cellulose, protein, nylon 66, terylene, etc. 4. Based on general physical properties. On this basis, polymers are grouped into three types. A. Elastomers. It is a general term used to describe rubber or rubber-like polymer. Elastomer can be defined as polymer having high degree of elasticity. It can be greatly deformed, stretched up to 8 times of its original length, by applying stretching force. But when the force is removed, it regains its original form. In general, the elastomers do not contain highly polar groups for hydrogen bonding. In unstretched condition, the polymer chains are not properly oriented, so-called amorphous form. But, on stretching, the polymer chains properly orient and acquire crystalline form. They soften on heating. Natural rubber is an elastomer. The polymer chains are held together by very weak intermolecular forces that can be easily overcome. A few cross-links between the chains help the polymer to regain its original position. B. Thermoplastics. They are the polymers which soften on heating and stiffen on cooling. In the softened state, they can be extruded or molded to any shape which is retained on cooling. This process of heating, reshaping and retaining the shape on cooling can be repeated several times without decomposition or change in chemical composition of the polymer. This property is desirable and valuable for the recycling of plastic. The intermolecular forces of attraction in thermoplastics are stronger than in elastomers. So heating is needed to soften them. The polymer chains are practically not cross-linked and are arranged in a haphazard manner. They are held together by weak van der Waals forces, so the chains can slide over one another on heating. C. Thermosetting. They are the polymers which change to an infusible and insoluble mass on heating. These polymers are normally made from relatively low molecular mass semi-fluid polymers which on heating in a mold form extensive cross-linking between different polymer chains, forming three-dimensional network to become insoluble hard mass. A thermosetting material become permanently hard when heated above the critical temperature and will not soften again on reheating. Because they undergo some chemical change, usually cross-linking, on heating and convert themselves into insoluble mass. So, they can be heat-treated only once and molded. That is, they cannot be recycled. 5. Based on structure. A polymer is said to be linear if it has only two end residues per molecule. But many times, they can be branched or joined together by cross-links or both. More extensive cross-linking may lead to the formation of three-dimensional cross-linked polymer, also called network polymer, see below figure.